Hello and welcome to our angles and circles review. The purpose of this video is to really highlight the four major theorems, the four major formulas that we've been exploring in the past couple videos. And I'll be honest, if you look at each one of those videos individually, you might think there's quite a lot of things that you have to remember. And the purpose of this review is to kind of condense all that material into just a few different characteristics to be looking for when trying to figure out which formula to use. And it all really comes down to one big question. And that question is, where is the vertex? If we can answer that question, where is the vertex, then we'll be able to decide which formula to use. So, the first situation, the vertex is at the center. It's at the center. So drawing in this angle here, we have a central angle, OAB, and I'm going to highlight the arc we're looking at here. This is going to be an arc of x degrees. So the central angle here is x degrees. Arc is x degrees, central angle is x degrees. So when you have a vertex at the center, what this means is that the measure of angle O here will be x degrees. Whatever the measure of the arc is, the angle equals the arc measure. Okay? Angle equals arc measure if it's at the center. Let's go on to the next scenario. The next scenario we're going to look at is when the vertex is on the circle. This is our inscribed angle. That's an inscribed angle, so we will draw in our angle here. P, AB. We've got our same arc here is x degrees, but this time angle P is going to be 1/2 of x degrees. So for your inscribed angle for the vertex on the circle, our formula is that the measure of angle P equals 1/2 of x degrees. In other words, the angle equals 1/2 of the arc measure. Okay, 1/2 of the arc measure. Okay. So inscribed angle, angle equals 1/2 of the arc measure. Central angle, vertex at the center. So this is central angle. The angle is equal to the arc measure. Okay. The next scenario that we covered was if the vertex is inside the circle. So the vertex is in the circle. By the way, this would also work for central angles. Maybe you can prove why. So the vertex is in the circle. We'll do the classic two chords that are crossing here. And we'll make them cross like this. We're not going to have these ones go through the vertex, and that's okay. AB, CD. Okay. And we'll have this arc here between A and C. This will be x degrees. We'll have the arc here between B and D. That'll be y degrees. And we'll be looking at our vertex here at angle P. So the measure of angle APC or DPB, either one, they're vertical angles, so they're the same. will be 1/2 of the sum of those two angles, of those two arc measures, x degrees and y degrees. So, in other words, the angle equals the average of the arcs. Okay, angle is the average of the arcs. I almost wrote angel, but it's the angle is the average of the arcs. And finally, the last one we're going to look at here, let me move this. The last one we're going to look at is, of course, angle outside the circle. So angle outside, vertex outside. Vertex outside. And this can take a couple different forms. It can be two secants intersecting, it can be a secant and a tangent, or it can be two tangents. Either one. We'll get to the two tangent ones in a bit. But let's just draw two secants. That's a nice representative of what we're doing here. There's P, there is A and B, and C and D. Again, we'll go with x degrees over here. X degrees there. We'll go with y degrees here. And the measure of angle P, this time it's clear what I'm talking about, measure of angle P. This angle right here. The measure of angle P will be equal to 1/2 of the difference this time. X degrees minus y degrees. 1/2 of the difference. Okay? We have a special case in this one. This always works for the vertex outside, but we have a special case that's just fun to know. You don't have to know this one if you don't want to. But a special case is the two tangents. So we have two tangents, A and B. Again, this arc here is going to be x degrees. And this time, the measure of angle P will equal 180 minus x degrees. That's a special case. That's really just this is the special tangents. Two tangents. So if we have two tangents intersect, we have this special formula here, but you could always use this outside formula. And on the outside formula, of course, the far arc here would be y degrees. So altogether, in words, the outside situation is 1/2 of far minus near. Okay? 1/2 of the far minus the near. And those are the four formulas you have to know. Vertex outside, 1/2 x minus y, 1/2 Oh, isn't that funny? I went this whole video and I got it wrong. That would be y minus x, shouldn't it be? I bet you caught that. So there it is. Hopefully you caught that as I was doing that wrong up here. That's embarrassing. But 1/2 of far minus near, 1/2 of y minus x, 1/2 of far minus near. Special one for two tangents, if you want to remember it, is that angle P equals 180 minus x. Then we have inside the circle is the average of the two arcs. On the circle is 1/2 of the angle of the arc. And finally, central angle is just equal to the arc measure. I hope this helps, and you can always go back and watch the individual videos for more in-depth conversations.